For today's geometry notes, we will start standard 8. You will need in class 33. We are beginning to talk about a new shape today called a parallelogram. So first and foremost, let's discuss what we need to know about a parallelogram, and then we'll see examples of how we can use those ideas to solve problems. Every parallelogram, first and foremost, is a quadrilateral. A quadrilateral is a clue about how many sides the shape has. Quad means that there are going to be 4 sides to our shape. And these are going to be polygons, so that means they'll have straight sides, they'll have corners, which means if there are 4 sides, that means we will also have 4 angles as well. But parallelograms are special versions of quadrilaterals because they also have 2 pairs of opposite sides, which are parallel. That's what gives it the name parallelogram. And that idea right there, a quadrilateral with 2 pairs of opposite sides parallel, is actually the definition of what it means to be a parallelogram. All right, now when that happens, there are all kinds of other things that occur along with our 2 pairs of opposite sides being parallel. First off, when we have parallel lines, that means we have a whole bunch of angle facts that we've learned in our Standard 6 and worked on in Standard 7 related to alternate interior angles, related to alternate exterior angles, related to consecutive interior angles, and then related to corresponding angles. Now, because we're dealing with a quadrilateral, a 4-sided shape, we won't have opportunities to see alternate exterior or corresponding angles, but we will absolutely have opportunities to see alternate interior angles. So I'm just going to write in a little reminder that alternate interior angles are congruent when we have parallel lines, and we'll also see consecutive interior angles, but those are going to be taken care of down here in some of these other properties that we list. Okay? What else is going to be true about parallelograms? Well, if we have a situation where both pairs of opposite sides are parallel, what also happens is that both pairs of opposite sides end up being congruent. Well, that ends up happening thanks to congruent triangles in CP/CTC. So if you're interested in understanding the proof for why that's true, make sure that you let your teacher know. Or you can go on YouTube, Proofs for Parallelogram Properties, and they'll be able to fill you in on the details for why. Another thing that happens is that 2 pairs of opposite angles end up being congruent. Again, thanks to congruent triangles in CP/CTC. And then we also have, this is where the consecutive interiors come back, we have 4 pairs of consecutive interior, but I'm just going to write angles because all of the angles in these pictures are interior. So consecutive angles are what we call them in parallelograms. And just like before with our parallel lines, consecutive interior angles were supplementary. And so these consecutive angles in our parallelograms are also supplementary. Now, if you think you're going to forget, make sure you give yourself a little note that supplementary means that they're going to add up to be 180 degrees. And then last but not least, another property of parallelograms is that the diagonals of the shape bisect each other. Now, this is a new use of the word bisect. So I'm going to draw a little picture here of a parallelogram. We need to draw it so that it looks like it has 2 pairs of opposite sides parallel. So they'd have the little flags to show that they're parallel. So that's parallelogram. The diagonals cross through the middle of that shape from opposite corner to opposite corner. So that would be one diagonal, and then this would be the other diagonal. So when we're talking about the diagonals bisecting themselves, we're talking about segments bisecting each other. Usually when we use the word bisect, it has to do with angles, but we're talking about segments this time. So what that really means is that that intersection point for the diagonals is a midpoint, not only for the first diagonal I drew in, but also for the second diagonal that I drew in. So we don't get 4 little segments that are congruent. We just get 2 pairs of congruent segments thanks to that diagonals bisecting each other property. All right, that's all the facts, believe it or not, that we need to know about parallelograms in order to solve the problems that are going to show up on your Standard 8 assessment. So the next thing we're going to do is try to apply that definition and those properties to find the requested values for parallelogram PQRS. So they're telling us in the instructions that all of these PQRS shapes are parallelograms. For each of these problems, we're also going to make sure that we're in the right mindset by circling whether the problem involves sides, angles, or diagonals, because that will help us to decide which of the properties will be used to build the equation.